like to welcome you to the paper session on interfaces for GLAM and CHIs. There's going to be three presentations in that session. Each one of them, and this is a kind remark to the speakers, is not going to exceed 12 to 13 minutes to allow for discussion later on. So I'll give the floor straight away to the team from Maastricht University in the Netherlands, Costas Papadopoulos and Gillikin-Schoueri are going to be discussing interfaces for 3D scholarly editions, a new paradigm for three-dimensional scholarship. So the floor is yours, Costas.
So thank you very much, Agiatis. It's very nice to see so many familiar faces and names. So let me start with a presentation. So last year, Susan Schreibman and myself presented on the relationship of 3D scholarly editions to John Ainsworth's scholarly primitives. So today, my colleague Gillikin-Schoueri and myself, also on behalf of Susan Schreibman, who could not be here, will present some ideas about existing 3D interfaces, explaining why these cannot serve as viable solutions for 3D scholarship. And based on some preliminary results of a user survey we conducted, we will also present some initial ideas and the way forward. So just to say that we're developing 3D scholarly editions as part of the Pure 3D project, which aims to build a national Dutch infrastructure for the publication and preservation of 3D scholarship. And we're doing that in collaboration with Clarion Dance, as well as many cultural institutions and organizations which have provided different pilot projects for the development of the infrastructure. But let me step back for a couple of minutes to explain what is a 3D scholarly edition. So 3D editions is still a somewhat novel concept. And while scholarly editions for text-based scholarship has had a centuries-long tradition, with digital scholarly editions being some of the first types of digital humanities scholarship, 3D artifacts, although much newer, tend to exist in a much, let's say, poorer contextual environment. In traditional scholarly editions, the objective of the textual critic's work is to provide a better understanding of the creation and historical transmission of the text and its variants, and this understanding may lead to the production of a critical edition containing a scholarly curated text. So we propose here that the 3D scholarly edition can act both as a theoretical framework as well as an infrastructure to support the affordances of three-dimensionality as a research tool and include robust contextual information. This could be textual or multimodal, metadata, paradata in various forms, including in-world annotation, supplementary site sources, and so forth. So in a way, 3D editions operate as fora for scholarly argument and critical debate for scholars to test out and critique the intent and meaning of those who formed, who used, and who acted within those historic objects or environments. So within the 3D scholarly edition paradigm, the 3D object, be it a single or a collection of artifacts or a virtual world, are considered the text of the edition, contextualized by multimodal apparatus. So a tentative definition we have for 3D scholarly editions is knowledge sites that provide a framework for 3D scholarship and the communication of the results, speculations, and theses of and around that scholarship. They provide contextualization and annotation about the 3D models and the objects or the worlds they represent. The scholarship is presented within a single spatio-temporal environment that is immersive, multivariant, and multisensorial. So in the process of designing and developing the infrastructure, and it is only 7 months that we have started working on the project, we're taking an iterative approach, also looking at existing offerings, both in terms of front-end interfaces, so what we would call conventionally 3D viewers, as well as the back end of existing infrastructures, in other words, repositories, databases, and so forth. So when it comes to 3D viewers, general online warehouses like Thingiverse, TurboSquid, 3D Warehouse, and probably the most well-known and used Sketchfab do not include the critical apparatus required for academic work, and thus they do not conform to our idea of a 3D scholarly edition. And the same is the case with the more research-focused digital libraries, such as Europeana or SciArt, which although have very different missions and priorities from pure 3D, it was worth looking at to observe the ways they have devised to display 3D information, both in terms of 3D viewers, as well as the contextualizing information. So in these more kind of generic interfaces, the standard search box dominates, therefore placing much emphasis on the value of the objects presented, including, not placing emphasis on the context or the relationship to other collections. So in these cases, also 3D models are arranged in a grid view, with a thumbnail of the 3D model. This is, in most cases, is a static image, includes some metadata about the object, such as the title, the number of views, if it's downloadable, the cost, if it's not free, licensing models, and so forth. And such presentation of a collection of objects is far from what Whitelaw has described as generous interfaces. And I quote, that offer rich browsable views, provide evocative samples of primary content, and support an understanding of context and relationships. And I would say it's worth looking at Sketchfab more closely, which is widely used by 3D creators, both professionals and enthusiasts in the gaming industry, as well as in cultural heritage. And Sketchfab at the moment is the standard viewer and often a repository for major cultural institutions such as the British Museum. And in several cases, Sketchfab is also used as the 3D viewer, also in Europeana, as it presents an easy way to embed and display the 3D models of individual objects, object entries. And let's look a bit at the interface of Sketchfab at an object level, because this is more relevant for 3D scholarly editions. So what you see on your screen is St. Barbara, and that's a wooden statue from the Netherlands Mine Museum that last year's students at Maastricht University digitized. The object is interactive, includes annotations in specific places on the object, and it's accompanied by a short description for which there is a word limit, I think 1,000 characters, some model information, licensing information, tags, and categories. Annotations can be added at specific parts of the object and can include text, hyperlinks to external sources, and can also have images embedded. Essentially, the interface of the platform provides some opportunities for contextualization, but the emphasis is on the object, not on how and why it was made. Also, the emphasis is mostly on individual objects and not multiple objects in the same view or virtual worlds, so much more complex 3D reconstructions that many actually researchers produce. There are some examples, such as the virtual Rosewood Cemetery, that is a more complex environment that has been uploaded to Sketchfab. And although not the best solution, Sketchfab has provided many functionalities that enable an engaging user experience. Still, though, the content that would make this a 3D scholarly edition can only be found in more conventional publication venues. So since in pure 3D, we don't want to reinvent the wheel or spend our time and energy into replicating what is out there, we started with an environmental scan of what we thought were the most promising 3D viewers. We compared them based on their features and used the best candidates to experiment with small-scale pilot projects. And at the same time, we also conducted a user survey so that we can start gathering user requirements that will inform the development of the infrastructure. And Kelly will tell you more about both the interfaces we have looked at and the user survey we conducted.
Thank you, Costas. So one of the viewer interfaces that we chose to explore further is that of Voyager, a 3D web viewer developed by the Smithsonian Digitization Office. We discovered that Voyager has a very user-friendly interface with clean and versatile features for annotation and narrative building. It also has nice features for model inspection, such as X-ray, measurement tool, and cross-section tool. However, one limitation to Voyager is that it is designed specifically for the Smithsonian Museum collection. Thus, the emphasis of the interface is on single object viewing and inspection, rather than on facilitating exploration of entire virtual worlds. The Aton framework is another unique 3D interface developed by the National Research Council in Italy. We wanted to explore Aton more because it offers unique features designed specifically for the heritage sector. Also, you could upload and annotate complex virtual environments as well as single objects. Aton's feature list includes real-time search functions within the 3D environment, the ability to mark change over time using layers, as well as what is referred to as a liquid system for deployment on different devices. The last 3D interface we want to highlight is the Virtual Interiors project based out of the University of Amsterdam. This project aims to create a spatially enhanced publication of a 3D virtual environment. Thanks to a recently released prototype, we have had the chance to engage with their interface, and it is quite user-friendly and has some interesting features that are not as common in other 3D web viewers that we explored. For example, there is a way to display a color-coded certainty index, which is important for reconstructed heritage contexts. Also, 3D scenes can be displayed in different pre-programmed lighting conditions, and you can even incorporate alternative hypotheses for different objects. These three examples of 3D viewers all have elements of what we call 3D scholarly editions, and therefore the best scenario would be to build on and extend the functionalities of one of those. But in order to do that, we ought to first gather some user requirements. So our goal is to take a user-centered approach across all stages of project and interface development. We're currently wrapping up the pre-development research and feedback from our three target user groups. The first is 3D content creators. The second is researcher end users. And the third group is our public end users. Thus far, we have conducted an intense literature review and environment scan, as well as conducted an expert survey for 3D research professionals. We will soon conduct interviews and focus groups, as well as control group evaluations when we have a working prototype. So we will soon be recruiting for these events. So if anyone would be interested to participate, please keep an eye out for announcements on our social media channels. So yes, our research survey was conducted in order to collect the needs and requirements of 3D researchers who would wish to publish their models and the associated work on the web. We asked a total of 47 questions on topics ranging from the respondents' personal and professional information, as well as what they would ideally like to see in such an interface. Additionally, there was an optional section where the respondent could answer project-specific questions. So on the following slides, I will show some results from the survey that asked about the respondents' desired features for a 3D interface.
Sorry, Kelly, you have about a couple more minutes.
Okay, I'll go fast. So this chart shows the results from question 6 of the survey. We used a 5-point Likert scale, and some of the highly valued features were measurement tool, cross-section tool, and the ability to toggle on and off different parts of the scene. This graph shows some less popular features, which were used to enhance some multi-sensorial aspects of a 3D research project. According to the results, advanced lighting capabilities and high-quality PPR materials were seen as important for a 3D viewer. Question 8 of the survey asked response about annotation capabilities of the interface. Results show that the respondents quite favor more versatile features for linking data and multimedia information directly into the virtual environment. Based on these and other survey results, as well as future user studies, we can begin wireframing an interface that goes beyond a web-based 3D viewer for simple model inspection to include interface features that incorporate modalities for connecting the model to its historical context by means of a detailed virtual research environment. So to conclude, our project is still in the first phase, but from our preliminary research, the case is a strong one for creating a more robust academic environment for 3D scholarship. The goal is to open 3D up to wider, more diverse audiences and to make this kind of atypical research outfit more visible for those who conduct their research in 3 dimensions. Thank you for your attention.
Thank you, Kelly and Costas, and thank you for keeping the time. I'd like to move now to Darío Negueruela del Castillo. He's from the University of Zürich, and he's going to be discussing maps, threads, and nodes, navigating hybrid modes of encounter and knowledge production with the Deep City Symposium digital platform. Darío?
So thank you. First of all, thank you, everyone, and thank you so much for the opportunity to present this fabulous annual event. Even though, of course, in virtual mode, as it happens to all of us lately. Actually, our presentation, I'm here together with Lucía Jalón Oyarzun, who's the head of research of Alice Laboratory, and Gordon Savage, working at Computational, who are actually the co-authors of this contribution, and we'll be presenting together. So basically, our presentation deals a little bit with this situation that we are all in. Kind of interacting in virtual mode. So as you have already read our title, I can already give the floor to Lucía, who will quickly give us a glimpse of what this Deep City Symposium was and why the digital platform is kind of relevant for our talk here.
Thank you, Darío. Yeah, the Deep City was a scientific conference that took place this year on March through a soon-to-be plug-and-play modular tool for hybrid conferencing. It was a conference on how big data, smart systems, machine learning, all these new technologies are changing the way we study, build, and manage our cities. So we wanted to consider this transformation along the resurgent interest in political concerns and contributive action, making one of the key questions of the conference whether the opposition of machine intelligence and democracy was inevitable, or whether there are shared trajectories between them still possible. These questions were organized around 6 topics that you can see on the slide. And for each of those, we hosted a paper session for more speculative, reflective, and scientific presentations, and a project showcase for more hands-on approaches and existing projects. Deemed to take place originally on November 2020, its planning got obviously derailed, as so many things, by the COVID-19 pandemics. And given our own interest in considering how our living environment is becoming threaded and molded by information, we considered it as an opportunity to develop an experimental tool dealing with that entanglement, how it could foster the forms of global dialogue the pandemics was bringing forward at that time when we started to see all these conferences online emerging all around.
So how did we try to do that actually? So and why this digital platform actually aimed at becoming something else than just simply the platform for hosting a symposium, but actually it aimed at becoming actual kind of a living archive. Basically, we started by this kind of obvious assumptions and some non-trivial challenges regarding the design of this kind of interface. As Lucía said, the current pandemic situation brought about numerous challenges and opportunities for the ways we interact with our peers and broader audience in the context of academic and research activities. For many, this has meant endless months of distant learning, teaching, collaborating through digital communication platforms and software in an unprecedented shift that has also brought screen fatigue and affected personal well-being and the quality of our social interactions to some extent. So, of course, this is undeniably at some point having an impact on knowledge production, learning, even innovation. And of course, arguably, perhaps this is due to the fact that physical presence in a way allows for a variety of modes of encounter and dialogue that include non-verbal corporal communication, oral and haptic communication, and a crucial sense of presence that affect our affective engagement with whoever we are engaging. In addition, we must add the tendency towards polarization that you all know due to social media, et cetera, and a lot of kind of dynamics that are at the core of our digital interfaces with the world at large. So, of course, this kind of realization in a way is a bit obvious, but not so obvious, kind of inspired also not just the themes of the symposium, but our approach to the interface itself. And we decided, so, do we have to adapt to this kind of role that we are given as kind of designers of these kind of interfaces, this kind of infrastructure at some point? Or do we have to kind of try to tackle precisely the ills that we already know that many of these platforms are bearing? Can they become political and social catalyzers to open up potential better futures in a way? I mean, this sounds very big words like usual, but yeah, this was kind of a question we had. So of course, being who we are, coming from where we come, we had this idea of space as obviously something that could have something to do with a potential solution, but obviously not in a kind of superficial and literal way. However, we suspected that at some point we saw that whatever was happening to digital interfaces was kind of mimicking or emulating certain processes that happened with the birth of big modern metropolis, at the turn of the last century, in the second half of the 19th century, where societies were passing from a rural communities to more industrialized urban societies. So this could bring about obviously segregation, but this could also bring about certain new modes of interaction. But what? So how do we go from this kind of reading from our own disciplines back to the interface design and conception? So in a way, what we thought is that we could maybe reverse some of the approaches that we were having to the city, and we could actually look back towards the interface with the same lens. And we thought, I will read it quickly, at the crossroads between the algorithm and the assembly, we stand somewhat paralyzed and capable of uttering viable alternative images, while the fabrication of our cities, interfaces, nowadays responds more and more to algorithmical logics of arrangement. They increasingly risk resembling past future dystopian images of inequality, control, and segregation to some extent. If we approach the interface as both organization of knowledge and social structure, we ought to rethink its guiding images. How can we sketch alternatives? Basically, this was a bit the departure point for our approach, and we wanted to do it with the notions that we know best. So, for example, certain concepts coming from architecture, urban sciences, such as urbanity, which of course talk about modes of co-presence, diversity, modes of interaction, softer modes of interaction, and so on. But of course, we wanted to apply this to the interface. So this jump is not obvious and non-trivial. And we are also dealing with a hybrid mode of interacting in a place where there's also not only co-presence, digital co-presence, but multi-presence, because you are in different places at the same time, these kind of interfaces, and also multimodality as we deal with different types of data and modes of interaction. So now we go to the platform just to give you a sense of what it was. Maybe Lucía, you can pick up from here.
Sure. So under these circumstances and with these ideas, and considering that our interactions in the physical world are deeply different from those on the digital world, even though they can have and are influencing each other, and we saw how these notions of urbanity could influence the way that we approach this. We started the design in collaboration with the Lausanne-based company Computed By and the computer engineer Gordon Savicic, who is also here in the room. We started to plan and organize this interface and hub. Well, you can see here in this screencast some basic features of it all. So it was a platform where through a map on the background, a map that wasn't purely localizing everyone in their physical space, but more on the shared symbolic space created through the platform. We could navigate through all the content, all the papers presented, all the projects presented, also see the biographies and contents related to all of our guests. You could also navigate not only through the map, but also through a text program on the left. And also on the bottom, you see the timeline where we try to bring all the time zones of the global audience that we were trying to mix. We were trying to make it so easy that this co-presence was felt as natural. So you are not having to do like all the strange numbers of, okay, plus 8 hours, minus 8 hours, but you could program the interface in a super easy way the moment you go into it to adapt to your time space. So suddenly you became entangled in a shared space where time is not that difference making between the participants. And all of this in the end implied a certain notions in design and implementation. So as we say, exploring the conference program through these multiple means, merging also the three distinct places that we were bringing together. There were activities in Lausanne, Hong Kong, and Singapore. They were brought together in this map. There was also all the videos in the platform. Each event had its own videos. Each of the videos and each of the event had different points of view to try to bring in the embodied. There was also this customizable front end that made the management of this all quite easy, and that we expect to make available so that people can actually use this tool without any kind of deep technical knowledge, no? To be able to do this kind of hybrid events. And also the switching between the map and the democracy wall that I will let Darío explain afterwards. And there were some challenges also that we wanted to acknowledge. So the scheduling across these multiple platforms, because it's true that we were using Zoom for the different conferences coming together. They were broadcasted through Vimeo. And also the videos became archived and post-produced in the same movement. So the platform wasn't only a place where you went to see something happening live, but where you have already the archive of the event happening as it goes. No? Then also the integration of third-party platforms, the release of early, it's true that it was an early prototype, and that we are now trying to develop into a polished end product that will, as I say, we want it to be available for other people to be able to use it. And Darío, if you want to, I let you explain the questions of the wall.
Just a couple of minutes left.
Okay. So then we kind of go fast. So basically, just this question that we had this environment that you could switch from a map to a wall. We will explain to you a little bit about this wall now. You saw a little bit the map. The map, of course, we were dealing with certain kind of inspirations about how to bring different spaces simultaneously in that kind of not representational, but somehow still symbolic way, where everybody could be still in their locations. And this is the kind of end product, bringing together like the real indoor spaces of different locations around the world, with some artistic licenses, of course. And of course, with certain kind of, references with a lot of pedigrees, such as the cyber scene, control room, and so on. Anyway, but of course, then we also had the other thing, the wall, where at the beginning it was meant to be an exhibition, but it was meant to also turn into something else. So the wall, it was the integration of this Miro platform into our digital platform, where we displayed a lot of different contents, and people could log in through our platform, of course, and not only upload these contents, but also we added all the papers that were presented in the conference at the same time, and they could comment, and they could link, they could pose their questions. We could somehow try to make it grow into a conversation, which was the point, to go from this static archive into kind of a living, ongoing dialogue in a way. That was a big challenge that we tried to pursue. Of course, they had other dimensions, such as the pouring over into the campus of the EPFL. So at the point, we were also projecting the wall onto some physical walls. So we were playing with these kind of notions with our team. And here in this screencast, you kind of show how you switch from the wall to the map, and the map to the wall, and then what kind of functionalities you could find there, and how this kind of grew and exploded as a real archive of this conversation. We hope to keep this going. There's different kinds of challenges ahead, and some of the extensions and the kind of things we'd like to address. So I quickly go to these improvements, and then we finish. So if you allow. So obviously we wanted to include other kinds of functionalities, such as semantic keyword extractions from abstracts. We wanted to provide DOI for video presentations, to somehow allow this permanent digital space for these poster sessions, and of course, evolve towards this capacity to run the whole video stream within our platform and not with third-party kind of software, and so on. So basically, I will kind of leave it here as we are running out of time, and I showed you just a couple of pictures of the event and how this actually required a lot of let's call it back-end assistance in a way, and a lot of people in place. So at the end, this streamlined platform did require a lot of human hands and minds behind. And this is the setting of the studio at the EPFL. Thank you so much.
Thank you, Daríah and Lucia. Thank you so much. It's been extremely interesting the way you explained how urbanity influenced your approach to interface. And that's quite a good lead-in for me to the Cyprus Institute team and Georgios Artopoulos, who will be speaking about computational annotation of architectural heritage. George?
Hi, everyone. I'm Georgios Artopoulos. I'm assistant professor at the Cyprus Institute, and I'm co-chair of DARIAH VCC3. On behalf of my co-authors that you see on your screen, and the other members of the project that we will be talking about today, I would like to express our enthusiasm for contributing and participating in this panel today. So, different from previous work in architectural studies, we are presenting today a tool that is based on artificial neural networks for identifying and comparing structure and architectural style of buildings from 3D data. We hope that our presentation will provoke discussions beyond the details of user interface of software platforms, and that will instead enable us to reflect on algorithmic methods and tools as new interfaces to interpreting complexity and generating knowledge. So recently, with the advent of the application of big data analytics in heritage sciences and architecture, as well as the access to computational power, segmentation and semantic annotation of structure of architectural structures of buildings was made possible, was enabled. And you see here a recent example of research that uses 3D point clouds of facades of buildings, repetitive facades, structures, of continuous urban fabric in Italy, to segment them and identify and classify parts of the building, like openings, doors, columns, arcades, etc. The next step in this research, of course, would involve the use of such methods as algorithmic methods in style classification. Which is kind of another beast, is more difficult. There have been many efforts in the past that are using photographs of buildings or plans and drawings of buildings, as you see on your screen, in classifying the style or the architectural, the period of a building. But this is sometimes not easy to be done because it's a much more complex cognitively process to be done only by judging, by observing a photograph, a 2D information. Actually, there are many cases where an expert would have to visit on site the building in order to observe not only its spatial context, but also its materiality, and in order to understand the historical phases as well as its provenance. So in the project that we are presenting today, we try to explore and experiment with the possibility to understand the potential of applying computational methods of annotation with deep learning in identifying and classifying not only the structure of a building, but also its architectural style. And we believe that this could contribute new interfaces that would allow, because of the use of reality captured 3D data, would allow experts to remotely access and observe a building in order to infer some hypotheses, as well as it could become a very useful didactic tool for comparative studies. So in detail, what the project UNFAS tries to achieve is the development of a neural network, the so-called OHRNet, that would take as input a 3D model of a building and would infer the position of each point of the point cloud as part of an architectural feature of a component of the structure of the building, for example, be it for a window, wall, door, etc., as well as to compute the probability of it being part of a specific type of architectural component that would be associated or linked with a specific architectural style or typology. Now, of course, this in itself is extremely complex and difficult for a challenge, and typically we would use what we call more canonical or archetypical, pure, clean examples of the styles that we would need to use in order to train the algorithm to identify and classify a new building according to a specific style. But rather, we try to make it even harder to ourselves and the algorithm, to push the algorithm even further. So we opted for using Cypriot built heritage as a material, as the examples of architectural of buildings of architectural styles that we would use for training and testing the algorithm. And I say that it's even harder because, as many of you might know, there are very few examples of built heritage in Cyprus that are not conglomerates, that are not mixtures of different styles, or that they have not been transformed by interventions through the centuries. As it has been put very nicely by Michael Given, in the future, archaeologists in Cyprus might find a very bizarre monument that would be a mixture of architectural styles, including Byzantine domes and column capitals, Gothic moldings and windows, Venetian lions, Ottoman lattices, Cypriot vernacular arches, and British coats of arms, which would make the archaeologists of the future wonder the identity and the culture of their builders. So I will try to quickly introduce you to some of the steps of the process we followed in order to develop this neural network, in order to understand the challenge, for you to understand the challenge. So first we started, of course, with identifying, selecting some examples from the various architectural styles or periods that one can find in the modern history of this island, of this country, spanning from Byzantine and Lusinian to Ottoman to British colonial and modernist. And you see here a list of the buildings. Then we had to photogrammetrically 3D document them in order to capture their materiality, and we had to optimize also the result in the generated models and point clouds for both online viewing as well as for the processing by the neural network. The next step involved us deciding on the factors, the architectural factors that would help the neural network to classify a building on a specific style, and of course to segment the structural parts, the architectural components. These factors included form and shape, the structure of the building or its material, as well as the openings like doors, entrances, windows, balconies, etc., and of course ornamentation. Following that, we had to identify all the variables, all the different types, all the different kinds of doors, windows, columns, balconies, etc., under these different periods, the different architectural styles. And this was very important for us in order to be able to map this variation to specific styles and then create a list of labels per style that would help help us train the algorithm and the algorithm to classify the building. Then we had to create a data set that would be annotated, that would be used to train the algorithm for it to be able to label the buildings. This, of course, was a major challenge because based on the capacities and the resources that we had in the project, it would be impossible to capture thousands of and process thousands of buildings here in Cyprus. And thankfully, we were lucky enough to have in our team Vangelis Kalogerakis and his collaborators, who have kindly shared with us their data set of annotated data set of buildings that we used for the training of the neural network of the project. And of course, we had to do the same to annotate the examples that we captured examples from the Cypriot built heritage. And we did this through an online interface that users would be able to select parts of the buildings and label them accordingly. The users of this interface were students of architecture, as well as experts who, through a series of meetings, they gave us their feedback regarding the usefulness of the labels that we listed, the accuracy of the representation of the buildings, the granularity of the annotated components for the segmentation, as well as the user friendliness of the interface. And you see here an example of segmented and labeled facade of a building. The next step involved the training of the algorithm, the learning process. And this is specifically with regards to the segmentation of the structure of the architectural parts is nicely demonstrated in this schematic here, where the 3D point cloud is pre-processed and then is subdivided in 3D data trees that are used for that are processed by the neural network and are labeled, and based on the location of the point cloud, of each point of the point cloud in the space of its voxel of the 3D data tree, which is called an octree, each point is labeled according to the features that are extracted, and it's further evaluated with the ground truth of the manually labeled models. And these are very promising results of this annotation process that you see at the bottom of your screen. The neural network has achieved to annotate accordingly the parts of the building. And finally, we had to build an online graphic user interface that would enable remote access to all these processes and all this information. So a user can browse the buildings by style or by period, and they can learn about their history. They can observe their materiality, as well as their the geometry of the building, and also study each of the segmented components, as well as they can compare different examples of built heritage by searching and putting them in the screen, in a split screen, as you can see here, with a mode visualization that would enable them to study individual components of the buildings, and as well as their geometry. And before concluding, I would like to end with an open question, our presentation today. So what are the affordances of approaching such algorithmic processes like the neural network we presented today as interfaces between reality and probabilistic 3D data-driven interpretations of reality? Do such processes, even though they are literally supervised, contribute new practices that are less curated than typical methods used in historical analysis and heritage dissemination? And what could be their impact in research and education if one would imagine the operation in the future of continuously retrained, integrated database centralized neural networks as interfaces for posing research queries? And I will leave that here. Closing, I just want to mention the members of the project that have not been part of this presentation today, and thank for their great contribution, Gustavo Pato and Vangelis Kaloterakis and their teams for their work. And thank you very much for listening.